Okay, so here's day 34. I'm going to go through these examples for you. So make sure that you are watching the video, okay, and then putting some observations in. All right, I'm not going to do that part for you. Okay, so 10 grams of lithium metal was placed in the beaker with excess water. How many grams of H2 gas will be produced? Okay, so remember when you're using the Bca table, the first thing that you need to do is make sure that it's in moles, because if it's not in moles, then you can't use the table, okay? So I see here what my given is 10 grams of lithium. Okay, so I'm going to need to convert that. Okay, so I'm going to go to the periodic table, and I'm going to see there are 6.94 grams of lithium in 1 mole of lithium. Okay, remember grams has to go on the bottom, so we'll be left with moles. And then, oops, I'm going to need a calculator. Okay, and then 10 divided by 6.94 is going to be 1.44 moles of lithium to start with. Okay, all right, so that's what we're going to start with. So let's first balance the equation. So I have lithium, H2O, LiOH, and H2. Okay, if you might remember when we did this before, it's easier to think of the H2O as an HOH. Okay, so I'm really looking at this H being the same as this H. Okay, so there's going to have to be 2 of those so that it matches up. Okay, which means I'm going to need 2 of these because now I have 2 H's and 2 OH's. And I'm going to need 2 of these and then just 1 of these. Okay, so let's just do a quick double check. So we have 2 lithiums, and then total over here we have 4 hydrogens. We have 4 over here and 2 oxygens. Okay, so that looks good. All right. Okay, so let's go ahead and do the Bca table. So if I have 1.44 moles of lithium to start with, that's going to be my before. Okay. Did it say excess? Yeah, excess water, so we don't really care about that. So let's don't bother. And then remember the products are always going to start at 0. Okay, if you don't really know what I'm talking about here, you need to go back a few days to make sure that you actually for real did the last couple things and didn't just copy from me or someone else. Okay, all right, so I'm going to go ahead and use up all the lithium to get nothing. So remember that change line is where all the important stuff is going to happen. Okay, so I'm going to use the base of 1.44, okay, and then I'm going to do the ratios. All right, so remember this is 1.44 moles of lithium, so I'm going to put the given on the bottom because I have 2 moles of lithium. So that's going to go on the bottom, okay? And then I'm just going to carry these coefficients down, 2 of these, and 1 of these. All right, so that's just going to be 1.44 times 1, same thing here. Okay, and this is going to be half, which is going to be 0.72. Okay. All right, so excess, again, we don't really care so much. Here, 0 plus 1.44 is going to give me 1.44 here and 0.72 here. Okay, so again, conceptually, make sure that you're thinking about this, okay? These coefficients are the same, right? So that means that 1.44 is going to be the same for everybody. The excess, we don't really care, okay? This is a 2, right? And this is a 1, so that means you're going to need half as much. So see here, I get this 0.72, which is half of 1.44, okay? Type of reaction that this is going to be, this looks like, since I started with a single thing and I ended with a single thing, this is going to be a single replacement, okay? My word equation, I'm going to say 1.44 moles of lithium react with, I'm just going to go ahead and say excess water, okay? I guess we can go ahead, since we have the states of matter, we can add these in. Liquid water to form 1.44 moles of aqueous lithium hydroxide. Okay, remember using your pink sheet for that. And 0.72 moles of hydrogen. I'm going to go ahead and say gas. Okay. All right, so now I can look and see what we're actually looking for, okay? And it said that I wanted to know the mass of the H2. Okay, so I'm going to need to use the moles of H2 that I have from the table, which is 0.72, but I want the mass. Okay, so I need to look at the molar mass. So H is 1.01, so that's 2.02. So 0.72 times 2.02 is 1.45 grams of H2. Okay, so that's my final answer. Okay, I hope I did not mess that up. All right, good.